لك الجدول اطلع عشان اول ما تسوي التسجيل يبين اسم الورك شوب. شير سكرين ما شاء الله. في داعي الو لحظه بس. ايه بونجور طبيعي. ايه كيف ماشي. اوكي شباب بليز لو سمحتوا الاي دي. اوكي شوف كيف بعت لك اياها هون على هذا الرقم. تخلقت معموله. لا ما خلص. جود مورنينج.
عند الرئيس ونازل.
مش متطور بس. ريكوردينج شغال. طيب اوكي. Good afternoon everyone. Are you hearing me? Good afternoon.
Yes.
Thank
I
you.
hear very well.
Okay. So, first of all, I would like to welcome you all on behalf of Beirut Arab University. I'm Professor Subhi Abu Shaheen, the Dean of Student Affairs at Beirut Arab University, coordinator of Erasmus Plus projects at Beirut Arab University. I would like to welcome you all at BAU Beirut campus for in both modes, face-to-face, present with my colleague from Lebanese University and from Jordan University. Good afternoon, Dr. Ghaith. مساء الخير.
Good afternoon. مساء الخير from Amman, Jordan.
الله يخليك.
I'd like to say hi to everybody. I was planning, as you know, I was planning to join you, but for medical reasons, I was not able to join you this time, and I hope I'll be with you in next time. Thank you, and I wish you all luck for a successful workshop.
Thank you, Dr. Ghaith. Dr. Ghaith is from University of Jordan, the project coordinator. Thank you, Dr. Ghaith, and hoping to receive you in the next activities in Lebanon at BAU as well as at Lebanese University. So we are meeting today in the framework of the Erasmus Plus project capacity building about the title DCARE project, developing curricula for artificial intelligence and robotic DCARE. Framework of the DCARE. This workshop is in the framework of the work package 11 about the collaboration with industry and community workshop. It's managed by the work package leader as Professor Clovis Francis from Lebanese University. We are holding this workshop today. Another workshop also will be organized in Jordan. So I will give the floor to my colleague, Professor Clovis Francis, to present an overview about the workshop, as well as to coordinate the first session. Dr. Clovis, the floor is yours, please.
Thank you, Dr. Subhi. Thank you for Beirut Arab University for hosting this workshop. Dear ladies and gentlemen, good afternoon. I am Clovis Francis from the Lebanese University, and it is my pleasure to welcome all of you in this workshop related to the collaboration university industry and socioeconomic sector. As Dr. Subhi said, this workshop is part of the Erasmus Plus project DCARE. So what is DCARE? DCARE is a capacity building project that aims at developing curricula in artificial intelligence and robotics. DCARE is coordinated by the University of Jordan by Professor Reis Abanda from UG. He is the general coordinator. It is our pleasure to welcome with us Professor Iyad Jafar from the coordination team, who will tell us in more details about Project DCARE. So this workshop is organized in 4 sessions. In the first one, we have a small overview about DCARE, and we have a message from the National Erasmus Plus office in Beirut. In the second session, it is our pleasure to welcome Mr. Ziad Shammas, head of ERA Lab Executive Committee, Mr. Ibrahim Mallat from Zani Trading Agency, Dr. Manal Jalloul from AI Lab, and Mr. Jad Wehbi from iTech Industrial Technologies. In session 2, we will present you the programs at Lebanese University and Beirut Arab University that will be updated by DCARE. In the third session, we have a round table that treats the sustainable collaboration between academia and industry. We have 3 speakers, Mr. Rami Mir from British Petroleum, Dr. Muhammad Khalil, and Dr. Ala Dahir from Lebanese University and from Beirut Arab University. So Professor Iyad Jafar holds a PhD degree in computer engineering from Wayne State University. He is currently working as a professor of computer engineering in the University of Jordan with more than 14 years of academic experience in teaching computer science and engineering topics. And he is conducting research related to digital image and signal processing and artificial intelligence. Professor Jafar will tell us about Project DCARE.
Okay. Can I have start the presentation?
No, go ahead. I will do it.
لو شغال اشتغل وين يوقف شو لا it's okay.
Go ahead. Go ahead. Okay.
Thank you, Dr. Subhi. Thank you, Dr. Clavis, for hosting us here in Beirut Arab University. So I will go very quickly over the basic concepts of the DCARE project. As Dr. Clavis mentioned, this is a 3-year project that is co-funded by the Erasmus Plus capacity building for higher education program, and it is coordinated by the University of Jordan. Now, the main goals of the and aims of the DCARE project. تقدر تنزلها Okay. To establish new programs and improve existing programs in different universities in Jordan and Lebanon in the areas of artificial intelligence and robotics. So specifically, we are aiming to establish a new master program in AI and robotics at the University of Jordan, a new PSC program in intelligent systems engineering at Tafila Technical University in Jordan, and also many courses will be added and many courses will be updated in different programs in participating universities from Jordan and Lebanon. Now, all of this will be done with the help of our European partners who have extensive expertise in the areas of AI and robotics. Okay, so the consortium of the project has members from 6 countries: Jordan, Lebanon, Italy, Spain, Germany, and Greece. 9 of these 10 partners are from higher institutions, and we have Creative Thinking Development from Greece, which is an NGO, and they are helping us in the quality assurance of the project. So the DCARE specific objectives we have many specific objectives, including qualifying experts in the AI and robotics, building and improving the teaching capacity of faculty members in the universities of partner countries in Jordan and Lebanon, improving the AI and robotics capabilities of graduates from existing bachelor and master's programs, improving practical skills of university graduates, as the project is focusing on the hands-on experience for the students, building networks of highly qualified professionals in the areas of AI and robotics, improving the collaboration with local, regional, and European industry and community. And this is under this objective, we are holding this workshop today, actually, and we are planning to have another one at the end of the month in Amman. And finally, disseminating and implementing modern teaching methodologies such as flipped learning and project-based learning. Now, to achieve these objectives, we are planning and we are working on introducing, updating, developing, accrediting, implementing around 45 courses. In the project, we plan to hold 19 training courses for faculty members and students. And we already started with this plan, and these courses are introduced by our European partners. The target is to train around 50 academic staff from Jordan and Lebanon and 25 students from both countries as well. The main outcomes of the project and the deliverables are reports to cover surveying the needs of AI and robotics, developing the syllabi of new and updated programs, specifying the main needs of industry, commerce, and society in the areas related to, in the domains related to AI and robotics. Also, some of the deliverables are manuals, such as a manual for good practices on the application of modern teaching methods, a manual for good practices for master program students on how to conduct research and how to solve the problems specifically related to AI and robotics. Also, the deliverables of the project include holding training workshops and events, as I mentioned earlier. So the added value of the project impacts the higher education sector in terms of improving the excellence and competitiveness of the higher education institutions and the innovative character of the planned results. Also, there is an impact on the society in terms of engaging partner countries in higher institutions in a new means of cooperation with employers and other stakeholders, and also planning measures to contribute improving lifelong learning approaches in the partner country institutions. So the target groups include engineers from related fields, as well as students, and as I mentioned, also faculty members and technicians in the higher institutions are also among the target groups. In terms of the progress, after around 14 months since the project has started, we have achieved a lot of things, and we are on the schedule, or maybe we are ahead of schedule. So we have conducted different types of surveys to identify the needs of AI and robotics in Jordan and Lebanon, and we have compiled different types of reports for this purpose. Also, the new master program in the University of Jordan, the curriculum is now ready, approved at the institutional level, and it is in the accreditation process at the national level. The bachelor program in Tafila Technical University is already approved and accredited at the national level, and in the project, we have prepared the curriculum to match the needs and the development that are happening in the field. Also, the existing in the partner universities in Jordan and Lebanon have been updated. The computer engineering program, mechatronics program in the University of Jordan, the master program in the Jordan University of Science and Technology, the bachelor program in computer engineering in Beirut, and the master program in Lebanese University. So far, we have conducted 3 training courses related to the project: Python programming, Introduction to Robotics, and Introduction to Machine Learning. Also, in terms for establishing and upgrading the teaching labs, The tenders in Lebanon and Jordan are finalized, and the contracts have been signed. And also in the EU, Dr. Subhi, it is also in the final stages. Yeah, it is in the final stages. So you can learn more about the project through different channels. We have a website and accounts on different social media channels. Okay. And that's it. Thank you.
Okay. Thank you, Dr. Ayad, for this presentation, for briefing the CARE project. It was established in Beirut in 2003 as the National Campus Office in Lebanon, and lately became the National Erasmus Plus Office. The Erasmus Plus Office role is to implement, coordinate, and promote the international dimension components of the Erasmus Plus program in Lebanon. In Lebanon, we are very lucky to have a responsive, supportive National Erasmus Plus Office coordinator. Now, I will leave you with the words of the Erasmus Plus program spelled out by Mrs. Yasmin Gharib from the National Erasmus Plus Office in Beirut.
Hello.
Go ahead. Hello.
Thank you, Dr. Clovis. Hello, everyone. So I am presenting today on behalf of Dr. Arif As-Soufi, the coordinator of the Erasmus Plus office in Lebanon. Thank you for having us with you today. I will be presenting the impact of the EU-funded project on the Lebanese higher education institutions. Before actually talking about this impact, we'd like to present the status quo of the implementation of the Erasmus Plus program in Lebanon, and particularly the implementation of the Erasmus Plus CBHE projects implemented by the Lebanese higher education institutions between 2015 and 2020. So during this period, there are a total of 27 capacity building projects implemented in Lebanon and 16 Lebanese higher education institutions, in addition to 11 other stakeholders that were involved in these capacity building projects. These 27 projects are divided between 7 national projects involving Lebanese partners, in addition to other 20 projects that are regional. These projects can be also divided between 21 joint projects and other 6 structured projects involving the Ministry of Education and Higher Education that tackle actually reforms at the national level in the country. So more information about these projects can be found on the link on our website. There is a comprehensive list of these projects with all details about the universities, coordinators, and partners. Now, as an overview of the priorities that were addressed by these 27 projects. So as we can see in this graph, that the 27 CBHE projects implemented by the Lebanese higher education institutions can be divided according to the following. So 9 projects are curriculum development projects, 11 projects tackle the issue of academia in relation to the socioeconomic sector, and other 7 projects address the issue of modernization of governance at the higher education institutions. This actually gives an overview, an idea of the implementation of the CBHE projects among the different Lebanese universities and the number of projects implemented by each university. For example, the Lebanese University has the largest number of CBHE projects implemented, a total of 15. And as you can see, the rest with the respective number of CBHE projects implemented. This graph also shows the implementation of the program with regards to another action, which is the international credit mobility under Erasmus+. So it also shows the projects implemented by the Lebanese higher education institutions, the ICM projects implemented between 2015 and 2020 For example, if we look at the St. Joseph University, there are about 100 projects implemented, and it's worthy to mention that every project includes a number of mobilities. So there are much more than 100 mobilities that are implemented by this university and similar to the other ones that are included in this graph. So actually the implementation is pretty good among the Lebanese higher education institutions with regards to ICM. Now, to look more in depth at the impact of the CBHE projects that are funded by Erasmus and implemented by the Lebanese higher education institutions. We at the National Erasmus Plus office conducted a national impact study report that studies actually the impact of these CBHE projects that are implemented between 2015 and 2017. Of course, more details about the study can be found on this link on our website. Now, as an overview of the study, it actually presents the impact on different levels that these CBHE projects had on the Lebanese higher education institutions. We're going to go very briefly over these in few, but it's good to mention here that and the framework of the 11 CBHE projects that are implemented between 2015 and 2017, the impact can be depicted as follows. So there are a total of 423 students that benefited from these projects and the different programs that were developed by these projects between this period. There are 282 staff trained. There are 46 courses that are either developed or improved. There are 45 internships conducted, 8 labs that were equipped, and some others are established. There are 45 MOUs signed, and there are 16 centers established. Okay, so if we look at the first level of impact, which is the impact on curriculum development, the curriculum development projects that were implemented between this period, between 2015 and 2017, actually developed a total of 35 courses at the level of, at both levels, BA and MA. 85 academic and 7 administrative staff have been trained in the framework of these projects. More than 230 students have directly benefited from the new programs developed. 30 internships have been conducted, labs have been equipped, and others, as I mentioned, 2 labs have been established. Many cooperation, European and Lebanese cooperation actions have been established. 2 research centers in the field of energy efficiency and renewable energy have been established, in addition to the development of a good number of modules, e-learning modules. If we look at the impact of these projects with regards to quality assurance, it is worthy to mention that the impact on the quality assurance was analyzed through the project, CBHE project Plus, that was implemented between 2016 and 2019. And as per this project and the framework of this project, the ministry has formed a special committee in 2010 to propose a draft law for the creation of a Lebanese Quality Assurance Agency. This was a very important outcome of this project. Though this hasn't been ratified yet, but the draft law for the creation of this agency has been revised and submitted many times to the Lebanese parliament. I would like also to mention a few points regarding the quality assurance, that in addition to this draft law that has been created, the quality assurance, this project has produced, have put in place a number of the internal quality assurance systems at a number of Lebanese higher education institutions. It also helped in having the culture of quality assurance becomes well rooted in the Lebanese higher education sector. Also, as per this project, the country has no more than 1 draft of the QA, the quality assurance standards, which need to be adopted or adopted by the universities. Also, as per the project, there is an important outcome, which is that a group of higher education experts active in the field of quality assurance have been produced. Now, with regards to the impact on students, of course, students are targeted by almost all the capacity building projects, and especially those that are about curriculum development. However, there's one important project that particularly addressed the role of students in their institutions, which is Tier Lab. This project, as per this project, there are institutional and national student structures that were developed and established in 3 Lebanese higher education institutions to ensure the democratic representation of the students in decision-making in these universities that were involved in the project. Another impact of the CBHE projects relates to employability. Here, the impact on employability can be analyzed in framework of the project Resume, which is about Mediterranean Network for Employability. This project has been implemented between 2015 and 2017. However, there are 2 other projects that are about employability that are implemented outside this period, Connect and Elegant, that also tackle employability. Here, these numbers give us an idea of the impact of this project on the higher education institutions that were involved. For example, 2 career centers were established in the framework of this project. One of them is Center Mean, which is at the level of the Lebanese university, the public university. This center has been well sustained and continues to be active and plays an important role in training, promoting, and providing assistance. In this regard, it's important to mention also that the project Care is also a good example of the relation with the industry. In the framework of the project Resume, there are 33 MOUs for internships that were signed, and there are also the Mediterranean Network for Employability was also created. Now, to take also a general idea or an overview of the impact of the CBHE project or on internationalization, actually internationalization was served to a certain extent by all the CBHE projects that are implemented in Lebanon. Some of them, for example, the project EUNIT has been directly addressing this issue, whereby the Lebanese universities that participated in this project have established EU units for the design and management of the international projects. Actually, these units, they helped improve the participation of these universities in Erasmus Plus and other EU international actions. In the framework of this project, it's worthy to mention also that some offices of international relations have been restructured. There is also another project that talks about internationalization at home. This is an ongoing project that also addresses the issue of internationalization implemented by 2 universities in Lebanon. Another impact is the impact on inclusion and refugees. This has been addressed by a number of projects. As mentioned here, there is currently an ongoing project, the Moral project, that addresses specifically and directly the issue of the refugees. And finally, there is the impact of the CBHE project on the teaching and learning. This impact has been analyzed in the framework of a project that is Talib. In the framework of this project that has been implemented, there was the Lebanese professional standards framework was developed and approved by the national authorities. There's also a postgraduate certificate in teaching and learning with 5 modules for professional development was developed and also accredited by the ministry, and 8 centers for excellence in teaching and learning were created in 8 Lebanese higher education institutions. So this was in brief the different levels of impact that these CBHE projects had on the Lebanese higher education institutions. Finally, the conclusion the conclusion of the study has provided a number of challenges that also can be lessons learned for other projects, which are basically challenges at the national level. In some cases, there is weak involvement of the ministry. There is weak cooperation between the universities, inter-university cooperation, and sometimes the involvement of the socioeconomic sector has been challenging. Another level of challenges is challenges at the regional and international level, especially when there are regional networks or centers that are planned, promised to be produced, they're not actually sustained in some of the cases. And finally, the issues of institutional ownership and the wider impact of the project are also challenges that continue to be seen in the implementation of some CBHE projects. So in light of these challenges, there are a number of recommendations that can be highlighted in terms of the institutional ownership, in terms of creating the multiplying effect and the issue of free training. Also, the impact and sustainability need to be taken seriously, not only during the proposal design, but also during the implementation. And the general recommendation about visibility is always the case. Finally, for the project De Care, we wish you best of luck. Actually, the results of the monitoring were very satisfying that we did at the level of the NAU office. And on behalf of the Erasmus Plus office in Lebanon, we wish you best of luck in the continuation of your project. And thank you very much.
Thank you, Mrs. Al-Gharib, for this presentation. Thank you for the continuous support of the National Erasmus Plus office in Beirut. We will move to the first session, which is related to academia-industry collaboration, best practices. The first presentation will be given by Engineer Ziad Shammas, Head of ERA Lab Executive Committee. Mr. Shammas is the President and Chief Executive Officer of Shammas Group of Companies. Mr. Shammas has over 25 years of experience in managing and establishing partnership with different companies and sitting on different specialized boards, committees, and associations locally and at the international level. Mr. Shammas is a board member of the Association of Lebanese Industrialists. He is a member of the Board of Trustees and head of the Executive Board of Industrial Research Achievements in Lebanon, an association that aims at building effective cooperation between the industrial and academic sectors in Lebanon through supporting, sponsoring, and funding innovative projects for youth. Mr. Shammas, the floor is yours.
Good day, everybody. Actually, I'm so proud to join this promising workshop. Looking forward to reach common targets on each program. I would like to start that there's a famous saying that let us think outside the box. So we ask which box we are talking about. Is it the regular box that we are used to, or the box at the innovation level, or the box at the dream level, or even the box of achieving the impossible? This is where we are now. The industrial sector is always in need for innovations with new ideas, concepts, and implementations. Success emerges from the creative minds of our young students. From here emerged the idea for the joint activity between the academia and the industries. It is controlled and managed by an association that included the Lebanese Ministry of Industry, the Association of the Lebanese Industrialists, and the National Council for the Scientific Research in Lebanon. This activity is not theoretical, it's practical. We are going exactly to the pain and try to solve and help whoever in need. With the support of the central bank in the previous years, we had done a great job. This activity is being executed by ERA Lab, the Industrial Research Achievement Lebanon, that had continued after the LIRA program. This activity promotes partnership between industrialists and academic researchers, encouraging students to innovate. I would like to share with you just one moment, technically. So the Industrial Research Achievement Lebanon is an association that got the permit at the end of last year, but it did not start last year. It had been working for a long, long time as under another name, LIRA program. It was a program, now it's an institution. It's between academia and industry. We will go into the list of agenda. We will go into those points. I would like just to let you see one of the most interesting photos that students, professors, and university presidents sharing the day of distribution of prizes. The structure of the association is the board of trustees that have executive board, executive management, and judging panel. Of course, the assembly, the general assembly, is the main structure of any association. So the executive board had members from universities, members from industries, and donors. The management is the head of executive board and executive director. Aside them, the most important part is the judging panel, trying to give prizes to whoever deserves. IRA-Lab objectives to building effective cooperation between industry, academia, and researchers centered to address the research and development needs of the Lebanese industry, match university researcher with the industrial need toward increasing productivity. Successful integration of multiple disciplines in the field of programming, mechanics, and electricity to develop existing production line or to manufacture new machine, resulting in production of more complex products. LIRA product activity program activities, actually it had focused on supporting and funding applied innovative projects in the field of industrial research for university students at an early stage until the completion of the project. We invite the university students to submit their innovative projects. We co-fund the selective submitted project together with the industrialist, and we depend on the panel of experts, the jury, to decide the winner based on scientific criteria. A very transparent scientific criteria. For the last 25 years, we had achieved 14 forums and exhibitions. 15 academic institutions had participated. 186 funded projects, 653 participating projects, 263 participating industrialists, and 168 projects employed by industry. Actually, this is one of the forums where we used to distribute the fund to students so that they will continue their projects. Now we have to move for a short, very short video. It is part English, part Arabic, but I would like to share it with you. Just one moment. I'm sorry, some technical. Okay, back.
أسس قصص نجاح عدة لطلاب لبنانيين لمعت بالقطاع الصناعي، مشاريع بحثية وابتكارات من أكثر من 20 سنة اليوم كان وراها برنامج إنجازات البحوث الصناعية اللبنانية ليرا، وساهم بتقديم الدعم المادي لإعدادها وتنفيذها. رح نتذكر سوا عدد منها.
الثروة الوطنية اللبنانية تكمن بالموارد البشرية والطاقات الطلابية المبدعة. لبنان بيتميز بقطاع صناعي متطور وواعد، بيقابله طاقات شبابية متعلمة وصاحبة كفاءات عالية. تسعى جمعية إيرالات من خلال برنامج ليرا لبناء جسر بيجمع ركيزتين: الإنتاج الصناعي الواعد والطالب المبتكر والمبدع. بيهدف برنامج ليرا لمساعدة الطلاب لإطلاق الابتكارات وخلق فرص عمل وشراكة للشباب وإطلاق شركات ناشئة وريادية، إضافة إلى البحث عن صناعات جديدة يمكن تطبيقها بلبنان. كل هالأهداف تعتبر فرصة للمستثمرين للتعاون مع الطاقات الطلابية الخلاقة وبالتالي الحد من هجرتها.
المشروع عبارة عن مكنة تصنيع عينين بلاستيك من الحب فل اوتوماتيك. مشروع هو كان مشترك مع الجامعة اللبنانية، طلاب آخر سنة، هو مشروع تخرج لهم وبالاشتراك مع مؤسستنا، ومن وقتها صار عندنا عدة مشاريع مشتركة مع الليرا بروجرام مع عدة جامعات.
هالمكنة عرضها علينا المهندس مشير الصياح، اللي هي معمولة من قبل تلاميذ من الجامعة اللبنانية، وهي صار لها عندنا تقريبا شيء 18 أو 20 سنة قامة بالواجب.
بدأنا التعاون مع برنامج البحوث الصناعية، برنامج ليرا سنة 97. في تعاون مميز كان سنة 2000 من خلال تصنيع مكنة بتقوم بتقطيع رولات الورق والكرتون اللي فيها مشكلة لإعادة تدويرها بشكل أوتوماتيكي. هذا الشيء كان يقوم بشكل يدوي. أهمية التعاون بين الصناعيين بين الأكاديمية ومراكز البحوث هي تمكين الصناعي من يقوم بابتكارات يلي بتعزز قدرته التنافسية والإنتاجية وتحويل الاقتصاد الوطني لاقتصاد منتج واقتصاد معروف.
نحن بال 2003 قدمنا مشروع على الليرا، كان هو اوتو بايلوت ديزاين سيميوليشن اوتو بايلوت لهليكوبتر من النوع المعقد. اشتغلنا فيه على سيستم للجايدنس وللنافيجيشن.
سنة 2003 قدمنا على الليرا لأول مرة. كان مشروعنا الهندسي، تخرج الهندسة عبارة عن آلة بتحضر القهوة اللبنانية بالطريقة التقليدية كأنها على الفحم. بكبسة زر تحصل على قهوتك. مشروعنا فيس سنتر طورني بالسنة اللي وراها، حضرنا مكنة تحضر قهوة لبنانية وغير أنواع قهوة. كمان قدمنا على الليرة وربحنا. نجاحنا هالسنتين متتاليتين كان حافز لنا إنه نقدر نصنع، نقدر نبتكر بلبنان.
هيدي الآلات تم تصميمها وتنفيذها بكلية العلوم بجامعة القديس يوسف. هدف هذا الاختراع تسمين النفايات الصناعية واستخراج مادة البوليفينول من عدة صناعات لبنانية. هدف هذا المشروع حل جزء بسيط من أزمة النفايات بلبنان يلي هن النفايات الصناعية مثل قشر الليمون، تفل العنب، ورق الزيتون وغيرها من النفايات.
بروشيد هو جهاز اخترعته من سنتين، هدفه يحل مشكله الاوفر هيتنج او الحماوه الزايده بتعاني منها سخانه الماء على الطاقه الشمسيه. هذا الجهاز بزيد فعاليه السخان للنص، بزيد عمره الافتراضي لضرب 2، وبوفر علينا حديث 30% من المي من خلال وقف هدر المي ووقف التبخر.
المشروع عباره عن الجوريثم هدفه انه يكتشف خصائص موتورات الكهرباء. هذا الالجوريثم قدر يشتغل على جميع انواع موتورات الكهرباء، والهدف هو تحسين الاداء وبنفس الوقت تسهيل التركيب.
المشروع هو تحديث منتج VVF موتور درايف للتحكم بسرعة المصعد. هالتحديث حسن أداء المنتج وزاد راحة الراكب بالمصعد، والأهم إنه سهل عملية التشغيل لأول مرة على الفني. ساعدنا هالشيء بالتسويق وساعدنا بزيادة بيع المنتج.
مشروعنا هو تو اكسس باراليل دلتا روبوت اللي بيعتمد على نيو تكنولوجي بالروبوتس. شاركنا فيه بمعرض الليرا السنة الماضية بال 2017. الهدف من المشروع صناعة آلة بتوضب المنتوجات بشكل سريع وستابيليتي عالية. قدرنا ننافس فيه شركات عالمية وصار انتجريتد بكذا مشروع عالمي.
هذا مشروع اسمه ريكوبوت اللي هو روبو متحرك، تم تطويره وتنفيذه بالتعاون مع كلية هندسة بالجامعة الإسرائيلية وبالتعاون مع مكتب الهندسي للشركة تبعنا. اشتغل فيه 4 تلاميذ من كلية الهندسة بالجامعة مع الشباب عندنا بالشركة. من أهم المجالات التطبيقية للنظام الريكوبوت أو الروبو المتحرك هو البنوك المركزية وبالأخص مراكز فرز الأموال وعدها، وكمان بيطال الصناعة على أنواع المطارات والمستشفيات.
هذا المشروع عبارة عن مكنة بتخلينا نعبي اللبنة بشكل أوتوماتيكي من التعبئة للتخديم بدون ملامسة اليد العاملة للمنتج وبطريقة سريعة جدا.
نحن كمعمل هذا المشروع ساعدنا بزيادة سرعة الإنتاج، حماية المنتج من البكتيريا وتخفيف الهدر.
هالمشاريع هي خير دليل على أنه الفكر والإبداع ميزة تفاضلية لدى الشباب والشابات بلبنان، وعم ينجح برنامج ليرا بربط هالقدرات باحتياجات القطاع الصناعي، وذلك بتعاون بين وزارة الصناعة وجمعية الصناعيين والمجلس الوطني للبحوث العلمية ومصرف لبنان. واليوم صار بضم برنامج ليرا أكثر من 12 جامعة شريكة من أكبر الجامعات اللبنانية وأكثر من 217 مصنع لبناني، والمسيرة مستمرة، مسيرة نحو اقتصاد منتج قادر على خلق فرص عمل وعلى تثبيت اللبناني بأرضه.
I do apologize for the long video, but actually I wanted to let everybody know very small part of what had been done during the past years. Now we'll continue with our presentation. So the ERA Lab program achievement and plans, the LIRA support for innovative use, industrial research, applied projects, and early phase innovation through LIRA Annual Fund and Forum for Lebanese Academic Research. New product development for Lebanese manufacturer, capacity building and incubation support for startups. We also work on investment and startup to bring investors to make the startup a real story. Knowledge and knowledge transfer for university to industry. International exchange knowledge for program for top innovators to share expertise with international market. Mapping industrial expertise to evaluate their performance in research and development and their willingness to cooperate with academia. Actually, we had established a network of local and international donors interested in supporting the international research to be active partners with ERA Lab. Actually, now I will ask my colleague, the executive director of ERA Lab, to join and continue the study and the mapping. Floor is for you.
Thank you, Mr. Shammas. I'm proud to be here with you. During my presentation, I will go through the annual fund that have been recently launched near the academia, where we ask the students and supervisors to apply for innovative projects and partake in LIRA program. In the second part, we will focus on the results of the survey on industries interested in R&D. So in reference to LIRA funds for year 2022, the purpose is to co-fund industrially applied academic projects. This project will be showcased during the LIRA 16 forum that will be held in November 2022. These academic projects should be supported by and co-funded by industrialists. Engineering and science students will conduct joint projects during their FYP, master and PhD programs. They will bind their project with industrial needs. ERA Lab, in this case, would co-finance these projects for up to 50% of the material costs. The ceiling that you have fixed, that has been fixed by the Board of Trustees, is 2,000 for graduating projects and 3,000 for doctorate projects. These amounts will be paid on the SIRAFA rates. ERA Lab qualified jury will evaluate all applications based on the criteria and conditions published on our websites. Final decisions on accepted project will be released 1 month after the application closing date that has been extended until 15 March. The fees that are covered by our LIRA fund are the mechanical, electrical, civil engineering, ICT, chemical and pharmaceutical, agro-food industries, packing and packaging, materials and nanotechnologies, and other industries that are not covered. Here we can include the biomedical also project that can be included in our scope. For this year, we have openings for new fields in the artificial intelligence, gaming, and e-learning. So for this year, we have asked applicants to focus on the following fields, like video gaming, virtual reality, AI, machine learning, and simulators. During the LIRA forums, the top 3 projects of each field will be awarded cash prizes, and additional prizes will be given to the best supervisor. Here in our next slide, we will go through some details on the procedure of LIRA funded projects. So in the first phase, LIRA conduct a survey. We conduct a survey near the industries to check what are the industrial needs of these industries. And they will, in these cases, identify the development needs that they would like to develop. In the second phase, we launched the call for projects. So here the academic institutions, they approach LIRA with an identified development need that has been already expressed by the industrialists, or they can propose a new idea. At the third stage, we conduct a matchmaking between the two, the academic project proposal and the industrial needs. So in this case, LIRA matches these projects, and a project evaluation is conducted by the jury. After the evaluation of the jury, we select the top project that we would like to finance. And here, LIRA will co-fund this project and help them to turn into industrial quality prototypes. Financing and implementation is our fourth phase. Now we move to the last phase of our program. Here we have different options. In option 1, the project that has been developed, it will turn into a viable innovation, and we will help these students to turn this project into startup. We will help them in financing, in capacity building near incubators and accelerators. Other option for this project, the prototype, will be employed by the sponsor industrialists, especially when the idea comes from the industrialists who would like to develop or improve any product or production line. And a third option is open for the student to connect top researchers with international industrial partners. Here, they will exchange knowledge and expertise in the purpose of launching viable startups or technology transfer. Now we move to the second part of our presentation, the survey results. As Mr. Shamas mentioned earlier, the survey conducted by ERA Lab team on January 2022 has been funded by Konrad Adenauer Stiftung, and it's still ongoing. It is based on the Ministry of Industry and the association and databases. We will share with you now the preliminary results. Final results will soon be published on our website and will be shared with all university partners. The survey on industries interested in R&D was divided into 2 parts. The first part was taking the industrial R&D expenditure. As you know, because of the predominance of the industrial sector in R&D, the R&D expenditure data are closely watched as an indicator for the development of innovation at the industries. In this case, in our cases, data will soon be published. So we will not go through this part. The part that we will develop now is the industries interested in sponsoring academic projects and in cooperating with academia for different purposes. Here we move to the industrial establishment that want to develop want to sponsor academic applied projects. So in our cases, we have like 79 industries that would like to become a sponsor for academic projects. 73 industries expressed that they would like to co-invest in spin-off companies. 143 industries would like to upgrade production lines. Around 100 industries would like to develop new production line. 125 industries would like to develop new products, and 158 industries want to foster entrepreneurship and employ these innovative students in their industries. In parallel to this information, we have gathered like 110 industries that would like to use the Lebanese laboratories for their own production and activities. So at a later stage, we'll get in touch with both parties and communicate all the information regarding these laboratories to the industries. By establishment size, as you can see here in our graphics, 61% of the sponsors hire over 50 employees. So if we look to the small and medium enterprises hiring less than 40 employees, you see that they are not really interested in sponsoring academic projects. Compared with the industries that hire more than 50 employees, which are really interested. So we have 20 industries hiring between 50 and 100 employees that want to cooperate with academia. 10, they are between 100 and 200. And 18 industries that employs over 200 employees would like also to cooperate. The total sponsor industries, as we mentioned earlier, is 79 industries. Now we move to the second graphics. The geographic distribution of industrial sponsors. As you can see, 80% of the industries are located in Matan, Jbeil, Kisirwain, Ba'abda, and Zahli. So 16 are in Matan, 15 Jbeil, 15 in Kisirwain, 9 in Ba'abda, and 9 in Zahli. This information might change after we finish our survey soon. The distribution of industrial sponsors by economic activity. We have like 42% of the industries in food and beverage. 12% they work in chemicals. 10% of these industries that would like to sponsor academic project work in rubber and plastics. 10% are in fabricated metals and 6% in mineral products, and the remaining part, clothes and machinery, are in less percentages. Now we move to the second part of the survey. Here we have gathered information on the interest of these industries to invest in startups, upgrade production lines, develop new production lines, work on new product developments, or hire innovative students and integrate their innovations. So we have gathered all these 5 topics into one data. We can also at further stage provide you with details for each one, and we will be publishing on our website. So if we take them all gathered in one item, the distribution of industrialists engaged that would like to engage in academia by workforce, you may see here that 50% of these industries hire over 40 employees. We have 29 industries that have over 200 employees, and 22 that have between 100 and 200 industries. Also for the small industries, we can also see that they are also interested in upgrading production lines, developing new products, and new product developments. In reference to the geographic distribution of these industrialists, we have 44 in Matan, 26 in Kisirwain, 19 in Zahli, and 16 in Ba'abda. The total of these industries is 200 industries. Distribution of industrialists interested in engaging by economic activity: 36% work in food and beverage, 11 in metals, 10% in chemicals, and 9% in rubber. For more details, you can visit our website, www.eralab.org, and we have also the Facebook leraprogram.com. Thanks a lot.
Actually, I do thank you. I do apologize for the maybe extension of time, but really the data is tempting, and we had spent a lot of time just to prepare real numbers, contacting all industrialist companies, all universities, just to bring the real mapping to base on it all the future studies. Wish you all the best. Looking forward to meet you again in other workshops. Thank you.
Thank you very much. Thank you, Mr. Shammas. Thank you, Mrs. Bal'a, for the presentations, for the data that you have shared. And thank you for your efforts in structuring LIRA program. And we wish successful achievements for IRA Lab. Thank you very much. So the second presentation is for Dr. Ibrahim Mallat from Z'Anni Trading Agency. Dr. Mallat is Director of FESTO Authorized and Certified Trading Center for Mechatronics Training. He will tell us about a very interesting and challenging training program from FESTO that is offered to engineering students in Lebanon. Dr. Mallat, the floor is yours.
Thank you very much. First, I'm not doctor. Ibrahim Mallat, that's all. On behalf of Mr. Z'Anni, thank you very much for this invitation. And I'm just coming yesterday from a business trip. I didn't prepare like real presentation, but I can give you some practical information according to our experience, especially in training. As you know, our company is not medium, it's like a large company in the north, in Kura. We have around 250 employees, approximately 40, we have in our company about between 40 and 50 technicians and engineers. And the idea from 2008, 2009 to create our training center in-house, the reason there's a big difference between the industry demand and the level of graduate from university and also from technical school. There's a big difference in demand. Okay, the university did a lot, but according to our demand, and our needs, we are in other view. In my view, there's what can I say? The curriculum at university, the title of curriculum is great, but the implementation of curriculum, I think, is so far. It's so far depending on the demand of industry. In 2009, Mr. Z'Anni have invested around $2 million in our own training center, especially to train our technician and our engineers before to send them to the real production. Let's give you only small example. Electrical engineer or mechanical engineer, they came to our company to find a job. They don't have idea what is servo motor, for example. What kind of sensor is it? PLC programming. They all information, they have it like theoretical. What is the need of industry is really a practical demand. And unfortunately, I think the practice is very weak. Even in technical schools, the practice is very weak. All the equipment is too old. The reason to cooperate with international companies, especially with FESTO or Siemens, to stay up to date. And that's very, very, very important. For example, we are producing mold, you know the clip or the Ambipure. We are producing the mold to produce bottle. How you can produce this mold? They have no idea. They have no idea. For in our company, we have software. We bought the software. The software is around $30,000, only the software. We train our engineer. We paid also another $30,000 only to teach them how to work with the software. And after that coming the practice, and finally we reach our goal. Now we have engineered the mold. If you want to buy a mold to produce a bottle, the cost in Italy or in Germany, the average cost between $1,000 and $500,000. Now we are obliged to produce our mold in-house, but we should teach our technician and our engineer how to produce it and what equipment they need. This information or this knowledge, they didn't get it in university. And the only way to reach our goal, we should teach in-house our technician and our engineer. That's like briefly the gap between the industry, the demand of industry, and the graduate from university. On the other hand, okay, now you have this artificial intelligence, but before this AI is something new. It's okay, it's new for us, but before the AI, they should learn from the beginning the ABC of technology. Really, we have engineers, they don't know the electro valve. They don't know how it's work, electro valve or sensor or servo drive. How you can teach engineers the AI technology if they don't know this basic? In my opinion, the practical part is very important. The labs and the equipment is very important, and also the cooperation with industry. I'm always, from the beginning, from the first year in university, the student should cooperate with industry to have this training inside with old engineer or with a special program, because in Lebanon, unfortunately, we don't have this special training center. What we need for each technology a special training center for all group, for all part. Because we don't have this special training center, Mr. Zani decided 10 years ago, more than 10 years, 2008, 2009, to have our own training center. Now, since many years, we are producing robot and machine in-house since many years, really. And we are ready for any kind of support in cooperation with university, especially with Lebanese university. We are ready to cover all costs of materials and equipment needed to have like a project, master project or bachelor project for students. And that's very important. The student, a group of students will come to our company, and we are ready for any kind of support, because especially in our days, the cost, if the students they want to prepare a final project, the cost is very high, and they don't have the money for funding. This kind of cooperation should be between the academical part and the industry. Let's briefly what I want to say for this workshop. We didn't, nobody tell us, only a few days ago, you should make a small presentation, but really we are ready for any kind of support, especially in training, in summertime, summer courses, special for project work. And Mr. Zanni is ready for to support in equipment, in material. Finally, otherwise, if the student, they will not do a real work, a real project in cooperation with company, that means nothing will happen. Thank you very much. And that's some critical point I want to make like flash to do. Okay.
Thank you, Mr. Mallat. Thank you for pointing out this issue. We are aware about this because we are academia people are working in their universe and industry people are working in their own universe. So one of the goals of this project, the CARE, is to fill this gap and to bring academia and industry people to work together. Please, I would like to point out that we have some surveys to be filled by industrials in order to point out what kind of collaboration within which framework of FYP, internship or other, or to provide us with seminars and to give us some, what are the strengths, some SWOT about strengths and weaknesses of our programs that will be presented in the second session. Thank you, Mr.
We are ready for any support. Okay, Dr. Globis, we are ready.
So the third presentation will be given by Dr. Manal Jalloul. Dr. Manal is NVIDIA Deep Learning Institute's certified instructor and a university ambassador. He is also the co-founder and chief executive officer of AI Lab. Dr. Manal Jalloul is also a lecturer and researcher at the American University of Beirut. Dr. Manal, the floor is yours.
Thank you, Dr. Clovis, for the introduction, and good afternoon, everybody. It's my pleasure to be here with you today. So I'm going to start by sharing my slides. Okay, here we go. Let me know if you can see my screen.
Yes.
Okay, perfect. So the title of my talk today is Academia Industry Collaboration to Upskill and Reskill in AI, specifically about bringing AI education to the classroom with NVIDIA. So AI is fueling innovation in every industry, and we are seeing AI and deep learning actually in our day-to-day life. It is in this type of products that we think to ourselves, how did they do that? So Siri, Alexa, Google Assistant are reducing the barrier of entry into the online world from knowing how to spell and search to knowing how to speak. Netflix, Amazon allow you to just filter through endless category of offerings to find out exactly what's right for you, powered by recommender systems. And then if you combine computer vision with control systems, this opens the door to autonomous machines, robotics, and self-driving cars. So deep learning is changing the world, and it is practically driving innovation across different sectors of industries. Like in robotics, AI models are being developed for manufacturing, construction, and navigation. In healthcare, AI is enabling smart hospitals and a new class of software-defined intelligent machines in hospitals. It is enabling cancer detection, drug discovery, genomics are all powered by advancements in artificial intelligence. Internet services, image classification, speech recognition, and NLP are employed to revolutionize the services there. In finance, AI is being employed for training strategies, for fraud detection in the cyberspace. In the media and entertainment sector, AI is powering digital content creation and game development and virtual reality. When it comes to autonomous vehicles, we see pedestrian traffic sign detection, line tracking, and advanced AI-enabled technologies are being implemented in state-of-the-art new generation of vehicles. So AI will bring a rapid increase of return of investment to the world economy. According to Forbes, by 2030, AI will create an estimated $15 trillion of GDP growth. By 2025, the global AI market is expected to be almost $60 billion, while it was only $1.4 billion in 2016. Only in the United States, $10 billion of venture capital is being invested into AI. In China, the amount of Chinese patents grew by 190% in a 5-year period. So their return of investment of AI is expected to be enormous, and it's time for people to catch up. According to IDC, they estimate that at least 80% of all applications will have an AI component by 2020. And there is an urgent need for the world's developers, data scientists, researchers to be able to get practical training on the use of the latest tools and technologies for artificial intelligence. From there, the NVIDIA Deep Learning Institute was established to offer resources for diverse learning needs, from learning material to self-paced and live training to educator programs, giving individuals, teams, organizations, educators, and students exactly what they need to advance their knowledge, not only in AI, but also in accelerated computing, accelerated data science, graphics, simulation, and more. So far, we've trained more than 120,000 developers worldwide, and the offerings at NVIDIA Deep Learning Institute range from getting started for beginners in the field to more advanced workflows in different application domains. All of these offerings are hands-on technical trainings that allow students to delve into the applications and learn the tools and latest frameworks that allow them to start building their projects on their own. Now, here in Beirut, I have established AI Lab a couple of years ago, and we have become NVIDIA Deep Learning Institute certified delivery partners in the region. Our mission is to help close the gap in AI expertise in the industry in Lebanon and the region. And to do that, we aim to help students, researchers, and developers improve their skill set in AI and equip them for the jobs of the future. So our complete curriculum of trainings is delivered in partnership with NVIDIA's Deep Learning Institute, and we have become the certified delivery partners of NVIDIA educational services in the Middle East and North Africa. So the question is, why collaborate with NVIDIA AI Lab and AI Lab for AI education? Well, we have several reasons why academic institutions may want to collaborate with us. Well, number one, access to technical expertise. Students, when they come to us, they're going to be learning from technical industry experts and instructors who are passionate about developing curriculum around the latest technology trends. We offer flexible training solutions where students can take online courses led by live instructor from anywhere with just their computer. All of this by using industry standard tools and frameworks where students will gain hands-on experience with the most widely used industry standard software tools and frameworks. And we allow the students to learn applications across different industries. They will learn to build deep learning, accelerated computing, and accelerated data science applications for industries such as healthcare, robotics, manufacturing, and more. And eventually they'd be able to earn certificates from NVIDIA Deep Learning Institute in select courses to demonstrate subject matter competency and support their career growth. They're going to be doing that by gaining real-world expertise through content that is designed in collaboration with industry world leaders, such as Children's Hospital of Los Angeles in our healthcare curriculum, Mayo Clinic, PwC, to name a few. By taking trainings with us, students will be able to access fully configured GPU accelerated servers in the cloud to complete the hands-on exercises during the training. This will allow them to build a production quality solution with the same DLI-based environment containers that were used in the trainings or available through NVIDIA Deep Learning Institute. So at AI Lab, our purpose and our aim and our mission is to help students learn and interact and innovate with AI and accelerated computing. At AI Lab, we strive to bring NVIDIA hands-on trainings and workshops which are being offered worldwide to the MENA region. And here are some of the universities that we have collaborated with during the past 2 years. And I'm going to give you just a glimpse of some of the trainings that we have conducted in the MENA region. At Rafiq Hariri University here in Lebanon, we've conducted the hands-on training on the fundamentals of deep learning. And also we've given the fundamentals of deep learning for computer vision at the American University of Beirut. For the Istanbul Technical University in Turkey, we've offered the fundamentals of deep learning workshop. And the American University of Dubai in UAE, we've offered also the fundamentals of deep learning workshop for computer vision. In Qatar University, recently we've offered the fundamentals of deep learning workshop. And also we have collaborated during past spring with the Continuing Education Center in EUB to offer a complete artificial intelligence hands-on NVIDIA training. In Bahrain, we've collaborated with Bahrain Polytechnique and University of Bahrain to offer the fundamentals of deep learning workshop. And during the Stanford Women in Data Science Datathon in Kenya, we have offered accelerated data science workshop. In Saudi Arabia, we've collaborated with Imam Abdurrahman bin Faisal University to offer the fundamentals of deep learning workshop. And we've collaborated with the King Abdullah University of Science and Technology, KAUST, in offering the accelerating data science workflows with Rapids workshop. With AI Lab and NVIDIA, in collaboration with NVIDIA, we have been able to train over 800 students and educators spanning over 8 countries and delivering over 20 different hands-on courses. In summary, academia industry collaboration can help to democratize AI expertise in the region and to complement existing academic programs. AI Lab, in partnership with NVIDIA Deep Learning Institute, helps to teach students, developers, and researchers how to solve the world's most challenging problems with AI. So it is time to tap in AI, and you are welcome to come and learn with us. Thank you.
Thank you, Dr. Manal, for this presentation that provides a very nice state-of-the-art on AI technology. So the fourth presentation in this first session is for Engineer Jad Wahbi from iTech Industrial Technologies. Mr. Wahbi is specialized in industrial automation and field networks. Since 2018, he focused on developing with different specialized team, a Delta robot, which is a parallel robot, a wind turbines, softwares with analytics capabilities, AI. All of them now has crossed the first prototype and working on the ready-to-market versions of each of them. Mr. Jad Wahbi, the floor is yours.
Hello, how are you? Thank you all for this meeting and presentation, and thank you, Dr. Clovis, and everyone for your time. I will take not much time, but we'll talk a little bit about our cooperation with the academic world. I don't know if you see me because, okay, so now I can. I'm not that good with these applications. So I will go through a little bit about our academic cooperation with the academic world. I mean, we have been, since we opened in 2007 or 8, we have been cooperating with major universities. So far, we have equipped many of them with automation labs, and also all based on PC-based automation. Because we believe that electrical engineers, mechatronics engineers should have a leading edge on some major softwares that can communicate with their machines in a very efficient way, using all the tools that they learn in their academic years, like C++ or Vision or the any kind of MATLAB or any application that can be integrated into the machine, so you can use and get the most out of your machine, to include whatever we call AI or robotics and motion control with some advanced and pushed algorithms. I will go through a little bit about our Delta robot just to show you. I don't know, do you see my, yes, I think you're seeing the screen, right? So we have developed the Delta robot. What we take pride in this is that we have developed it all, from the mechanical system to the motion control to the electrical cabinet, and most importantly to the vision system. And every time that we want to do something, we go to universities and take internships and collaborate with students, because whenever we want to test the water in something, we give those students a very specific task, which always includes a lot of research and a deep depth in the information. To later on, we can collect all these data and put them together so we can get something out of them. So if we look at the robot, for example, it's a whole system that contains many different aspects. Some of them is mechanical, like every single item or mechanical items require a lot of mechanical designs with kinematics, and it requires mechanical engineering interns, also with our mechanical senior people that can help and form a group to have all the mechanical design, especially the formulas that will determine the strength and the ability, also the dimension of the machine. So also there's a lot of accessories, like whatever you need, joints, you need other than joints or grippers or whatever it is required. So believe me, there's a lot of information inside this. The electrical design also with the communication, industrial communication and wiring between, from the servo motor to the servo drive to the PC-based automation to other sensors and push buttons of the machine. So this is also a complete different world. And here also we take interns and people from the electrical and computer engineering to develop and enhance this. For the computer science, we also work with people on the vision and on the algorithms to develop complicated HMI for the same machine. I'm just showing in one machine how much systems are embedded just to form one piece of action. When we see it, we call it a simple piece of action. I will show you a small movie in that. So I already removed 1 minute out of this video, just to show you the outcome of the first robot. And now we are developing the second version, which is way faster, it has many other functionality that I will not mention. So last but not least, I will show you also our software, we are also, so as you can see, just to conclude on that robot thing, that all these kinds of systems are all put together, and believe me, it's a work of many groups of engineers to come up with this system. Going to another application we're doing, it's also under the automation. It's called, we call it Anasoft. It's analytic software. Also has some AI capabilities. It is also, we're developing this software since 2 years now, already having the first prototypes that are doing some data analytics for industrial applications, where it can be used to detect preventative maintenance and workflow and other main functionalities. Okay, so this is some screenshots of the software. And I wanted here to share, to show you every year we have number of internships that will register with our company. Having these interns usually will help us later on also to hire some of them. With this way, we do our cooperation with the universities. Also, we have labs in many universities, and already we have given more than 200 courses for 200 engineers. We do them on a monthly basis, but lately in the past 2 years, it wasn't easy because of the COVID and all the situation. But we are still running in the same direction, and always looking to go forward with this and with the academic work. So thank you for your time, and happy to have you to have shared all this information. Thank you
very much for this presentation. I would like to say that you are an inspirational example that I give to my students to develop their entrepreneurship spirit. Thank you for being with us. Please, for all the presenters, if possible, to share with us your presentations. We can take some data of your presentations to well document the project. I will open the floor for 2 minutes of questions, if any. Okay.
I don't know if Mr. Shammas is there or not. For your yes, I would like to ask a question.
Okay.
Yes, Mr. Shammas, many thanks, Yani, for your presentation, comprehensive overview about ERALab. So, especially in AI, have you identified some project in AI, and what the main possible contribution or partnership with universities in AI this coming year? Because I think either both partner universities in this project, Lebanese University as well as BAU, we are ready to cooperate. Especially we are a partner with LIRA since its beginning. Yani.
Actually, to be very accurate, the project starts from the university and from students. And when we find students interested in presenting project in AI, we will continue to find a jury for AI and industrialists in AI. So the issue is the other way around. We are ready to be very, very cooperative. As we said now that, let's say, for example, e-learning, we got some information about some people interested in supporting and sponsoring e-learning projects. This is why we introduced e-learning to see students going into this direction. Of course, we are interested in AI. Of course, we appreciate this future era. And we are working intensively to extend the availability of industries that are interested in various sectors. This is why we did the mapping. This is why we spread and we know what are the availability in Lebanon in terms of incubator, accelerator, and research and development offices. In this issue, we are working actually without a promise. We are working intensively for some funds just to see what are the industries and universities that are having research and development activities, but they don't have enough budget. So this is part of the interest. So as long as the university or the institution, if the university or industry, they really have interest in research and development, so we have a short list that those people deserve to search for them for funding. So I don't know if I answered the question. The AI is a major part of our interest.
For sure, we will communicate, for sure. Thank you.
Thank you. We can have one more question because we are at some 10 minutes. Is there any question? Okay, if not, thank you very much. Please, in the invitation, we have 3 surveys. The first one is for industry. The second one is for academia people. And the third one is to evaluate the workshop itself. So please go through those surveys. They don't take too much time, not more than 4 to 5 minutes per survey. We appreciate if you can have the time to fill them. So we will have 15-minute break and we will be back in 16:50. So we'll have we will be 10 minutes ahead of our schedule for the second session.
Please stay with us, remain with us.
Thank you very much.
Thank you. Okay. Record. Go ahead.
Okay, ladies and gentlemen, we will resume our workshop. We'll move to session 2, which is related to curricular enhancement for Lebanese University and Beirut Arab University. The first presentation is for Dr. Subhi Abu Shaheen, Dean of Students Affairs at Beirut Arab University. Dr. Subhi is a very active person. He is the head of the EU-funded unit at Beirut Arab University. At the time being, he is part of 7 EU-funded projects, and he is coordinating one of them. Dr. Subhi, the floor is yours.
Okay, thank you, Dr. Clovis, and thanks to the project coordinator also, Dr. Ghaif Abanda from University of Jordan. And many thanks to all participants with us and who stayed with us until the end of the project, because usually once we start, we have a huge number, then after that it decreases. But now we are still more than 30 participants virtual, and we are here 15 participants at BAU. Please close the door, Ala. In fact, as Dr. Clovis, also the work package leader, professor at the Lebanese University, would like to highlight the main achievement and the main activities of the CARE project at BAU. But before that, let me just, I will not be late. No, I will not be late, Dr. Clovis, for that. I will give a brief history about BAU, the Faculty of Engineering, as well as the computer engineering program, and what has been done for the CARE project in the framework of this Erasmus Plus project regarding artificial intelligence curricular enhancement. BAU Beirut University, as all of us know, it's one of the largest private higher education institutions in Lebanon, founded in 1960 and accredited by Foundation of International Business Administration from Germany. It includes 4 campuses and 10 faculties, 45 undergraduate programs, around 90 postgraduate program, over 8,500 students, and over 113,000 alumni worldwide. We have, as I said, 4 campuses. Yesterday, our colleague from Jordan visited the B campus. We are in Beirut campus. We have 1 Tripoli branch and 1 campus in Beqaa region, my region. Regarding the number of undergraduate students for the electrical and computer engineering program, this is for 2020-2021, for example, in communication, we have 164, computer engineering 127, and the computer engineering, by the way, and computer science student, the number of the enrolled student increases. There is a demand on that, and I think the track of artificial intelligence in this regard will also, I think the number of students will increase also. And at the same time, we have a new program, the biomedical engineering program. It started 3 years ago or 4 years ago, and the number of students increases, and also we have many applications on AI for the biomedical engineering program, and Dr. Ala Dahir from BAU will speak about that in the next session. Regarding the labs, existing labs at BAU for the computer engineering program, we have digital system laboratory, measurement and electronic laboratory, software laboratory, network and cybersecurity, biomedical imaging laboratory, biomedical instrumentation laboratory, in which we have some AI application. And thanks to Erasmus Plus programs, we will establish a new AI lab in Beirut Arab University, financed by the Erasmus Plus project. These are some research activities, or are the topics in which we have hardware design, embedded system, software system, AI, artificial intelligence, and all courses in this regard are being enhanced, multiple valued logic, deep learning, as our Manal Jalloul explained, Dr. Manal Jalloul explained today, antenna design, mobile computing, cybersecurity, etc. And in our future activity, we will combine all these topics or all these activities to have a comprehensive system, especially in collaboration with industry, from radio frequency to communication and electronics to AI, to have a complete system. Regarding our project for DCARE, we are working in the 3 work packages to improve the current curricula in master program in Jordan and Lebanon. We improve curricula also at the bachelor degree level in Jordan and Lebanon, and we are establishing also and developing artificial intelligence and robotic lab. These are in progress. And we selected to enhance our new courses as elective courses, to also reduce the effort for re-accrediting the program from the Ministry of Education and Higher Education, because in this case, we just either enhance existing course or introduce a new, of course, recommended elective course for our students. Lebanese University, you don't need that because you are the public university. Also, to develop the syllabi almost completed. And for sure, we need the approval of the modified and added courses to existing master program from the governing university board in BAU at Beirut Arab Universities. And I think the last university council, Dr. Adel, this was endorsed by the university council, and for sure, we will inform the Ministry of Education and Higher Education about the update of this program. Computer engineering program, what are the new development for this program? Before the DCARE project is in line with our program. We have 2 tracks. We have the track artificial intelligence and machine learning track, and all the courses in line with this track. And we have also another track, network and cybersecurity track. So the student can choose both the tracks. And for sure, we'll collaborate with the biomedical engineering program to have some industrial application for AI. For the computer engineering program, these are the courses where we decided to update or to insert new elective courses. programming for engineering, introduction to artificial intelligence and machine learning. These are to be updated, are being updated, pattern recognition and deep learning. And we introduced two new courses as elective courses in the track of machine learning, AI, machine learning and introduction to robotics. Regarding the master courses also, 4 new courses, cognitive robotics, computational aspects of robotics, reinforcement learning and autonomous system as elective courses, and updated existing one, fuzzy sets, logic and application, neural network, data mining, and the pattern recognition. By the way, we selected these courses according to the needs analysis, and after that there is a committee from the consortium members of the project. These courses are first developed, then are being revised, and finally we have some training on these courses as Dr. Ayad Jafar from Jordan University explained today about the outcomes of the DCARE project. Also for the computer science program, we have another computer science program in BAU at the Faculty of Science. We can improve the content of AI course and benefiting from this DCARE project. So we will update the course in line with the DCARE outcomes. At the same time, we are preparing a lab of AI. We have visited that in yesterday. We have finalized the selection of the equipment and the provider, but unfortunately we didn't find in Lebanon many providers for AI equipment, especially due, I think, to the existing situation in Lebanon, due to the economic crisis, due to financial problems, due to the stability, the political stability of in Lebanon. We couldn't find too many providers, but finally, thanks God, we found what we need exactly, and we will start the purchasing procedures, I think, in the next weeks or next week, or maybe, I don't know. This is one of our activities in the DCARE project also, about raising awareness of the DCARE project in BAU last November. And this also, just to tell Dr. Arif Al-Sufi, I don't know if he is with us, and yesterday we held two common events with the Elegant project. The Elegant project also, it's an Erasmus Plus project in which we participate about the enhancement of employability of graduates in the IT and development of IT program. AI is one of the IT sectors in which we are developing our course. And at the same time, this workshop, Dr. Clovis, the collaboration with industry. In the other project, we have to create also a liaison office with industry. And so these two projects are to complement each other. And one of the recommendations of the audit visit from Lebanon as well as from Jordan, I think, either from EU, was to reinforce the collaboration between one project is complementary to other ones, and so on. So thanks, Dr. Clovis. Merci beaucoup. Voilà.
Thank you. Thank you, Dr. Subhi.
Thank you.
Voilà. I wish you all the success in your continuous effort to drive BAU and the higher educational system in Lebanon, because you have a position at the Ministry of the Higher Council of Education. So thank you very much, and wish you all the best.
Thank you, Doctor.
I will present you also the set of courses that we intend to update at the Lebanese University.
One moment, Doctor, to share screen.
You already shared.
No.
Voilà. Presentation mode. Okay.
Voilà.
So,
voilà. It's okay. Go ahead.
So thank you very much for being with us. Thank you, Professor Res Abanda, coordinator of DCARE. So this presentation is on behalf of Dr. Rafi Younis, Dean of the Faculty of Engineering. I will present you the master programs that is going to be updated by this project, DCARE. So briefly, here's a small presentation related to the Faculty of Engineering. We have 3 sections. The first one is in Tripoli, is section 1. The second one is in Mount Lebanon, Rumi. And the third one is in campus Rafiq Hariri Hadath. We have the Faculty of Engineering has been founded in 1980, 40 years ago. We have almost 2,500 students over the three sections. We are accredited from CTI, Commission des Titres des Ingénieurs, which is an independent French organism for accreditation. We have 4 specializations in civil engineering, electrical, mechanical, and chemical. So by means of the CARE, some courses of the electrical and the mechanical engineering departments will be updated. Yes. So here's briefly the master degree in industrial control. It has been launched in 1999, more than 20 years ago. It's a double degree with the University of Technology Compiègne in France. In 2016, so each 4 years we go through some update of this program, and since 2016 it became master in robotics and intelligence systems. Up to now we have more than 250 graduates, and some of those graduates are actually at the time being colleagues at Lebanese University and other universities in Lebanon. So this program will be updated by our program DCARE in its AI and robotic components. What is this master program? So this program that is running in double degree with University of Technology Compiègne, as I said, it deals with intelligent transport system. We have research related to global chassis control and autonomous vehicle in a multi-vehicle context. We perform some trajectory planning and we study some the vehicle dynamics, and we introduce some control laws in order to enhance maneuverability and the stability of the vehicle. The second axis is related to fault tolerant, and it's applied to flying robots. Those are the drones that we have at the Lebanese University. So the purpose is to introduce some hardware and software redundancy in order to give the system with a new dimension to be fault tolerant. And we introduce FTC in the perception system, in the control laws, in order to introduce some robustness in our system. Those are some examples where we use optimization techniques and machine learning in the presence of uncertainties related to data. Here's the master program that is going to be updated. We have 8 courses and within 30 ECTS. Those are the faculty members from Lebanese University and from University of Technology Compiègne involved in teaching. So in red, we have the courses to be updated related to optimization, advanced data analysis, identification and control of systems, advanced statistical learning, diagnosis and fault tolerant, nonlinear control applied to robotic system. And in green, we have a new course that is going to be developed within DCARE related to advanced robotics. In the second semester, it is a 30 ECTS also. It is totally dedicated to the master thesis. Out of our BE program, we selected some courses based on, as Dr. Subhi said, on a needs analysis and based on the competencies that are offered by the project DCARE. So we intend to update some courses at the BE level that are provided within the electrical engineering and the mechanical engineering departments related to computer vision, sensors and IoT, robotics system. So all those courses are related to develop robotic system. So those courses will be updated. We will have some training courses will be developed by the EU colleagues, member of the consortium, to give us best practices and to share with us their experience in this field. So that's it. Thank you very much. It is very important before opening the floor for some questions to please to our industrial and colleagues to fill in the surveys and to give us your feedback related to those programs that are going to be updated. Also, our academia people also to fill those surveys and to fill also the surveys related to the workshop evaluation. The 3 links are in the invitation, and we will put them also on Zoom. Thank you very much. I will open the floor for discussion. One moment. So here we have the three surveys. It's really simple surveys related to industry, instructors, and to the evaluation. Okay. If no more questions, you can. Okay. If there are no questions, we move to the third session, which is a roundtable entitled "Towards a Sustainable Academia-Industry Collaboration." In this roundtable, we have 3 speakers. We'll start with Engineer Rami Mir. Rami Mir is an automation advisor for British Petroleum. He has a 17 years experience in energy sector and currently holds an automation advisory position at BP America. He has an extensive experience in offshore, upstream, and onshore downstream design, commissioning, and operations area. He holds a BE degree in computer engineering from NDU and an MS in management from University of Houston. Rami is continuing his education in leadership management at Harvard University. Rami, thank you for being with us from US. The floor is yours.
Hello, Doctor. Thank you for having me. I know you always reach out and you always try to get me involved, so I appreciate that. Can you guys hear me well?
Yes, yes, yes.
Okay. So I'm going to share my screen so I can start with my presentation. Please let me know when you see it. Just give me a sign.
Yeah.
Okay. Can you guys see it?
Yes, yes.
Okay. So my presentation mainly is very specific to the oil and energy industry. We're going to be focusing on AI and automation applications for the oil and energy. The agenda is going to be, I'm going to go very quickly because I know I have 15 minutes. So I'm going to go very quickly. I'm not going to go in details, but I'm going to be very clear about the application. So first, I'm going to give a quick overview of the oil and gas industry, about 1 or 2 minutes. And then I'm going to be speaking about the automation, process control, and AI applications, specifically in the upstream industry. Okay, so on the mainly on the offshore production platforms. The takeaways are going to be zooming into the oil and gas and energy efficiency AIs, and we're going to be also talking about understanding the real industrial applications and benefits. Specifically and lately, BP and other super majors have been focusing mainly on CO2 emissions. So CO2 emissions has been added to all our softwares. So all AI and BOTs are also focused on CO2 emissions lately. I would say in the last 2 years. Also safety and production has been also prime. So starting with a quick overview. Let me move this to the side. Okay. I just want to make sure you guys can see my presentation. So just give me a yes if you do. Okay. So first, the oil and gas is separated to three main sectors: upstream, midstream, and downstream. Today, we will be focusing our analysis on upstream, which is the exploration and production. So we're going to be also focusing on the production piece. I know I've seen few presentations, and most of them are focused on the general aspect of AI. But we will be focusing on one aspect, so we can, I feel like we're missing zooming in on one specific sector and one specific industry. Midstream is basically transportation of raw petroleum to refineries. Downstream is refining the process. So just to give you a quick overview to tell you where we will be zooming in. So if you can see my cursor, we're going to be zooming into the production sector of the upstream business today, okay? Trying to move, okay. So upstream production overview. So basically, just to give you a quick overview so you can understand where the AI application and the advanced process control is going to be discussed. On the right side of this slide, you can see you have the production wellheads where the wells are connected to the production facility. So the production wellheads are connected to separators. So you do have the separators which separate the oil and gas from a first stage perspective. And then this goes to the second stage, then cleaning and crude pumping. And also the gas goes to the gas compression and then the metering, then to the pipelines. And also you do have other utility systems on those facilities, okay? So again, I'm zooming into, if you can see my screen, to the upstream production sector, which is production facilities, which could be a TLP or an FPSO or any production facility that produces the oil and gas, and that happens after drilling, okay? So I'm gonna stop here to see if you guys are on the same page or you have any questions, so I can move on to focusing on the technology aspect and on the process control and AI of those systems. So I just want to make sure you understand where the focus is or where I'm trying to zoom in.
It's clear.
It's good?
Yes.
It's good, doctor. Can I move on?
It's clear.
Okay. Okay, so this is how a real process overview looks like on a DCS system, distributed control system or SCADA system. This is the main page. So this is the complicated one line of the process. So it shows the production manifolds, and I'm showing this page so you can see how the sensors are connected, if it's pressure, temperature, to every and each process line. From the oil gas section on the top, the oil section here in the middle where you can see my cursor, and then at the bottom where it shows the gas compressions, okay? And then this goes all the way from the extraction to the compression, then to the cleanup stage, then to the pipeline and metering stage, okay? If it's gas at the bottom or oil at the top over here. And then you also can see little utilities like power generation, for example, emergency generation, treating, oil treating and things like this. Why am I showing this? Because the AI system or the advanced process control system is going to be looking at those at this data to be able to analyze and make decisions based on many things, okay? And we will get to the details later. So I just wanted to show this slide to kind of give a one line of how sensors and are connected from subsea to topside to power generation to gas compression to other modules. We call them modules. So that's what this slide shows. Now what I was asked as well is to show how automation is used in the industry. So the automation is used for many aspects. The first aspect is to monitor the data from the field, which is at the bottom of the screen. You have the field IOs and different technologies, could be field bus, could be other type of communications. Also to the electrical controllers. And then it goes to the PLC controllers on this layer. Then it goes to the server and historical data. And then it goes up to the DCS where it reads the process data. Also, it's used to control equipment, to stop the plant. And then you have DOTs that are also used to for preventive maintenance, to increase the plant efficiency, which is a huge player lately, especially that companies like BP and Shell and others are really focused on CO2 emissions, and especially that governments are also finding and giving credits for decreasing the CO2 emissions, which is something that also needs to be focused on with students, I believe, soon in the future. Also, less human interface errors. That's why data is used, and we will get to this later. There is a slide that shows the percentages. Also using historical data and data analysis, which is getting into the DOT and AIs of those systems. Also zooming in at the automation piece, which uses mainly PLCs and RTUs, using automatic startup, sequencing controls, controls of machinery and protection, could be turbine compressors, pumps, surge, speed, and process variable controls, which takes a lot of quick compilers, up to 4 or 5 milliseconds are needed for those type of applications. Also protection, performance, monitoring, preventive and predictive maintenance is what really saves money these days. And also makes the plant safer. So quickly going through a definition for performance monitoring. So the latest performance monitoring I worked on a few years ago was GE System 1 monitoring, which looks at the rules of, we call them rules, meaning those rules come from the vendor, that the original manufacturing vendor, OME. So the OMEs are the people who set the rules for their machines. For example, if you look at the bottom of this slide, you can see a turbine, and this turbine is an LM2500 made by GE Oil and Gas. So GE makes those turbines and set the rules for those turbines. For example, if a specific temperature hits with a specific vibration, then your machine on a specific stage or on a specific condition, then when you get these rules, you can then say, okay, my machine needs maintenance within 1 year. Okay, I'm just giving a very simple example. So when these rules are set and you have your sensors connected to that server and you get that information, then basically you did predictive analysis, and that information is sent automatically to our rotating equipment department, which schedules automatically a maintenance for that machine. And this is a feedback loop that gets calculated every day. So you have a very specific trend for predictive analysis. So basically, I do have a couple of slides. I'm gonna skip here. Yeah, and doing reactive or preventive maintenance costs really cheap comparing to losing a machine during process or operations. Okay, so this is pretty convincing why we need preventive maintenance. So if you can detect at an early stage when the problem starts, you can schedule fixing a machine. So I guess no need to convince. I mean, these are things that are intuitive these days. So also wanted to show the cause of production losses in refineries, mainly mechanical failure, and that's why we invest too much in predictive maintenance and AI or machinery learning. So I think this is another example of RTU monitoring and collecting data by solar turbines. Wanted to throw this out here. This is a little technical for this workshop, but just wanted to show you guys those. Okay, so here it shows the DOT pattern interpretation. So within those servers, we do have DOTs that look at all these curves, okay? For example, this is a pattern interpretation for a sticking, for a crank angle, okay, for a sticking shaft that is, or sticking valve, sorry, that shows the ideal curve versus the measure curve. So the BOT software will look at the ideal curve and will give you an alarm and report telling you, hey, you need to look at this valve and see how you need to fix it the quickest possible. Okay, this is another interpretation of how BOTs are linked to our systems. That's another one. Okay, and this is the slide I want to talk about the most because I think it's very relevant to what we're talking about today. So AI, how is AI used to produce more, to get more stability from our oil wells and oil and gas wells? And why do we use it? Okay, so these are real examples that I wanted to share with you. So over here on the left side, where I'm circling my mouse, you can see the gas lift. So we have gas lift that lifts the oil up to the risers where the oil rises, and then this oil is basically controlled by these valves here where I'm pointing my cursor at. So these valves basically are connected to a very smart slug controller, which is down here. And this slug controller has a theoretical explanation here, which we can get later into details. Whoever is interested, we can talk about these, but basically we have a lot of information, a lot of pressure sensing and temperature sensing, which all goes into these equations, which is applied into functions here like a low pass filter, and then they go into the controller, the algorithm, and that algorithm controls a boarding valve. Okay, one valve can do all this difference, believe me. And this predictor, or this AI, uses a model which predicts where the plant is going using historical data. So basically we have about, for this specific one, we have about 64 PID loops, which are connected together with variable set points. So these variable set points are linked together, and they are dynamic set points, and they are calculated based to get an optimum operating point, which give us the maximum economical and safety range, and also gives us a predicted analysis for the downhole pressure, which is the pressure in the riser in the well, and gives us a calculated set of control moves that actually moves that boarding valve. Okay, the boarding valve, which every well has a boarding valve. Also where my cursor is the boarding valve. So by moving this valve, you can actually affect the pressure in the well, which is about, could be 10 miles down this line. Just by moving this valve correctly, you can make basically, you can have a very much safer and very much more controlled plant if you know how this AI works, or you make it work right. So this is basically my quick presentation. I think I did take 15 minutes. A lot of information. So do you guys have any questions for me? Technical questions or non-technical questions?
Thank you, Rami, for this presentation. Thank you for presenting this complex plant.
Yeah, I'm sorry about that, Doctor. I just couldn't do it simpler than that.
People from academia, we like to see what we are teaching to the student, where it is used, sensors,
yes,
monitoring, diagnosis, and so on. I am sure that using AI technology in the field of all paves the way for new interesting applications in monitoring, diagnosis, and so on. Thank you very much.
Hoping we will have production of petrol in Lebanon.
I hope so. Okay.
I actually have a question for Rami, if you don't mind.
Yeah, it's okay.
Sure.
So I was wondering, how are you? What kind of board are you using for implementing AI at the edge?
What kind of board? You mean what kind of hardware?
Yes, it's AI at the edge, right? You're not streaming the data to a server or anything. You're running the model on an edge device to do the predictive analytics.
Actually, we use a virtual server for all this. So we have all the PLCs and distributed control systems, and we call it PHD. It's a Honeywell database collection, uniformance database collection. So we have about 75 different types of controllers that are connected to a virtual server that does the calculations for this process control system.
Okay, thank you.
If you want, you can get with me offline and I'll give you more details.
Of course I will. Thank you, Rami.
Okay, thank you very much. The third presentation is a shared presentation between Dr. Muhammad Khalil. He is the director of Azam Research Center in Biomedical Engineering and its application. He is also a professor at the Lebanese University Faculty of Engineering. He has more than 100 papers in international journals and 170 papers in international conferences.
Only.
And the second part will be given by Dr. Ala Dahir. He was our former student at Lebanese University, and at the time being, he is assistant professor at Beirut Arab University Biomedical Engineering program. So he received the PhD in Artificial Intelligence, Advanced Signal Processing and Automation Engineering from the University of Normandy, Rouen, France. So, Dr. Muhammad and Dr. Ala, the floor is yours.
Thank you, Dr. Clovis, for this presentation. Are you seeing my screen? Everything is good?
Yes, we can see.
Raise your voice, boss.
Yes, thank you. I would like to thank you for inviting me to present the activities in the Azam Research Center. In fact, I would like to choose some idea about the presentation related to the CARE program and the relation with industries. So I will present the Center of Research in Biotechnology, and then I will present some activities in biomedical engineering, like the new assistive technology for disabilities, the brain-computer interface, the exoskeleton, which is really related to this conference. And then I will present quickly some research related to uterine EMG and some research related to electroencephalogram, which is something related to depression, Alzheimer, Parkinson, epilepsies. And I will present something related to industries and hospitals with the Azam Center in Biotechnology. So the Azam Center is related to the Doctoral School for Science and Technology. This is located in Tripoli. At the same time, we have two other centers, one in Fanar, which is called Nanotechnology Platform, and the other one in Hadas, which is about analysis and environmental sciences. In Tripoli, in the Azam Center, we have 8 laboratories. The biggest one and the biggest laboratories in research and in activities with industry is the medical microbiology. We are working now on corona. The biotechnology, the technology in medical and industrial system, which is my laboratory. Networking and telecommunications, informatics and modeling, mathematics and application, and physics. I would like to just speak 3 words about every laboratory. The first one in biotechnology here, we are working on pharmaceutical and environmental, agriculture, and chemical and energetic. In my laboratory, we are working on signal, neurophysiological signal, image, AI for image processing, instrumentation, and informatics, and AI for signal processing also. And also we have a team who is working in telecommunication and telemedicine, control system for handicaps and so on. So we are working in real-time implementation. We have big team in biometry, and we are working a lot for handicaps. And we are using signal and image. The new team formed in brain interface, in brain research. We are working on brain-computer interface, on pathological disorders. I will present also some word about that, and the picture naming. And we have developing new tools, and we developed a tool which is called EEGNet, and is presented in the most famous journal, which is Nature. In our laboratory, we have a lot of facilities, and we have now a lot of materials which is used to acquire the signals, the EEG, EMG, EKG, any biomedical signal. And we have also materials for accelerometer, in biomedical, goniometer, pulse oximeter. We have a lot of material really that is used for research. And the most important material now is acquiring to EEG, which is used for 38 electrodes, which is new in Lebanon. In the laboratory on bioinformatics, they are working on archiving. They are working with hospitals and in modeling. And the medical microbiology now, they are working on microbiology, on corona research, on corona. Really, we have at least million and million of microbes that they are used to do our research in collaboration with Institut Pasteur in Fez. Okay. This was the acts of research in laboratory. In fact, the most important part here in this research center, the strong point is the work with multidisciplinary, because we are grouping together in the same center: biology, mathematics, biotechnology, bioinformatics, and we are working together. And this is a research center for engineering, for sciences, for public health faculty, and for administration. We have a lot of collaboration with France. I don't want to nominate all the universities. We have really a lot of collaboration. We have collaboration with Germany, Great Britain, University Libre de Bruxelles in Belgium. And in Lebanon also we have collaboration with AUB, USG, and the BA. In fact, our research center answers the needs of enterprises and society to be developed at local, regional. You will see after. We we have a lot of collaboration with hospitals, with the Ministry of Public Health, and also with agroalimentary enterprises to do protein analyzers. We collaborating with medical centers and with the Union of Municipalities, and also the Laboratory of Microbiology is collaborating with Halab Society. They are developing new techniques to protect more times the sweet in Halab industry. So for the biomedical team, the most important part that we are working is the brain-computer interface. Imagine that you are thinking, we acquire signal, we extract features, we classify, we know what you are thinking. This is the aim. We know what we are thinking, and we can command a robot or command something related to your thinking. This is called brain-computer interface. For example, imagine that you are looking for a letter, and we are typing the letter just by looking, because you analyze the signal when you look the letter, and we know that this is the classification given the letter, okay, the letter that we are looking for. And also imagine that you are looking for a color, and we know which color you are looking for, and we can comment, and we can do some command for a robot or for anything else related to the color. The most important thing related to this DCARE program is a BCI related to robotic exoskeleton. Here we have 2 PhD students with Créteil. Imagine that you think that you want to go up on this stair, and you cannot, and you are wearing exoskeleton that it can help you. So we can take the intention, we analyze the intention, we can command the exoskeleton. So you can go out or go up of the stairs without any thinking, and the exoskeleton which can help you without any problem. This is really very, very important in the future, and it will work very good. Look, for example, it can help this person to walk. It can help this person to work without any get tired. And in the future, the army are using this one to help the military to go to the mountains, and that can help to stay long time without anything. Also, we are collaborating also in robotic teams with rehabilitation centers. For example, in Hospital of Al-Rahma in Tripoli, we are trying to command a wheelchair by commanding it by EMG activity, and also to recover the spinal cord injury using transcranial electrical stimulation. This is very, very important. We are working now in collaboration with the rehabilitation centers. The most important thing in research now in our laboratory is the multi-signals. Instead of using just one signal, we can acquire multi-signals. You can use multi-electrodes to acquire one signal. And for these many signals, we can create something which is called the graph theory. This is really new, and we are now publishing a lot of publication using graph theory. What is graph theory? Quickly, if you have many signals, you can, for example, calculate for every 2 signals I and j, the relation between them, the relation between I and j, you can call it xij. For example, you are calculating the correlation or the relation. Maybe something is called correlation, or something is the convolution between both signals, or the energies. Anything. We have many things to calculate the relation between any 2 signals, and you can continue all of that to calculate all the relation between any 2 signals. So you will transform your signals to a graph, and this graph you can characterize it. So that means you can extract parameter from a graph, and you can classify. And at the end, you can use the neural network, the artificial intelligence program, to classify using this graph. And this is used in 2 very big applications now in our center of research, which is the first one, which is about the detection of preterm deliveries. What is detection of preterm deliveries? That means we can put the multi-signal on the abdomen of the woman. We acquire multi-signals, and from these multi-signals we acquire all the signals, and then we acquire the graph. From this graph we can plot this graph for the pregnant woman 6 weeks before labor, 3 weeks before labor, or at labor, and you can classify if this woman will give birth at labor, at time, or before time. This is very, very important. It's very important to classify, and really we get good result. We arrive to 95% of good classification using this graph theory, because we are using not only one electrode like before. This year we are using 16 electrodes, and from 16 electrodes we can acquire more data to classify between two signals. So this is very important. Look, for example, the model of pregnancy, from 8 weeks before labor up to labor. So we can see the graph is changing in terms of time. So we can classify the graph to see what is the problem. The second part, the brain network. Brain network also related to the energy between signals, and the aim is to use multi electrodes. Look, here we are collaborating with Rennes in France, and we acquire 265 signals. 200 in our laboratory in Tripoli we have 38 electrodes. Here we have 268. This is very important, so we can have the signal EEG, that we have very, very good temporal resolution, because the sampling frequency is 1000 Hz. That means every 1 millisecond we can know the state of the head. This is very important. And from this signal we can acquire all these signals, and we can get, and we can do an inverse problem, the inverse problem to see from where this signal is coming inside the head. And if we know from where this signal is coming, so we can use it to do many applications. The first one is the picture naming. Picture naming, what this means? This means if I see the apple, I want to say this is an apple. From seeing the apple to saying this is an apple, we can follow. For example, when we see this is a cortex part, we can see inside the brain what is happened. This inside, from cortex to temporal part to decision part, we can see where is the decision part, where is the memory, and when I say apple, this is the articulation part in frontal part. So from occipital part to frontal part, we can follow, and we can say if really everything is good in the brain and everything is working good. And if someone sees the apple and he cannot say apple, and if he wants to say another one, we can see also the network. We can classify that this is good or not good. The second application quickly is the Parkinson. The Parkinson also we have many group of Parkinson, mid Parkinson, severe Parkinson, and we classify the network inside, and look, for example, we have the big difference in network. To classify between Parkinson and severe Parkinson. For epilepsy, also look these images for epilepsy, not epilepsy, or not epilepsy and epilepsy. So we have big difference in the source of signals when we say that we have epilepsy or not epilepsy. The first application is Alzheimer. Also Alzheimer, we have big difference between persons, and we can follow because Alzheimer now. In fact, this is the biggest part of research in signal processing, because really the number of Alzheimer in the world increased. We arrive now to 74 million people around the world. So it is really it will increase according to the WHO. So the research now is increasing. So we can say between the control and the non-control. Look the activities here. For normal person and for Alzheimer disease, look, the activities is not very good. So we can say the part inside the brain which is not working. And the last part, which is new in our laboratory, we have one PhD and one master student on that, which is about major depression disease. The depression. We are detecting where is the part who is not working. And we have depression, and if we detect that, and we are working with some doctors to put an electrode inside the brain and to inject some pulses to make the person happy without taking any medication. You see, so this is the aim in the future. So I will finish by our relation with industries. In fact, as you know, the Azam Research Center is an RTD. Research and Development Research and Technical Development Center, and we try to improve the MPE competitiveness by investing in the acquisition of new knowledge for RTD providers. We are working as you see with hospitals, to testing machine as a quality control, and here we are working with the Ministry of Public Health. We are developed we developed program for archiving. We are working on bacteria with hospitals, and also we are making now new research in bacteria, and especially now for corona. In biomedical field, we are developing a new instrumentation, and we developed many instruments for disabled persons, and we are implementing some sensor network in hospitals to follow the patient from one stage to other stage for a specific doctor. Also, we are for SME in biotechnology. We did some research on the composition of elements, and we have for packaging. We have now a new patent on that, because they developed a new tools to put on the lemon to protect it during the exportation to other countries. So it will take more time to be protected. Also, for pharmaceutical, we are developing some program. Maybe Ala will present someone concerning the detection of the kind of bacteria. Also, if some candidate medicine, we are testing this. We are working in collaboration with some NGOs to work with that. And also, we are working with NGOs for research on environmental, some water decomposition, because we really in the ASM Center we have many materials, and we are working with all these NGOs to help them to detect the bacteria or the decomposition of water analysis. Okay, so I finish just by saying that we are the RTD performance, and we are waiting, and we can work with many SMEs and enterprises to validate our project, and we are developing a really new technique for all the SMEs. Thank you very much. I will let the floor for Ala now to present his work. Ala started with our university, as Dr. Clovis says, and now he's working with, in collaboration with us at Arab Beirut University.
Thank you for the presentation.
So Dr. Ala, as I said, he is assistant professor at the Computer Engineering Department of Beirut Arab University. So Dr. Ala, the floor is yours.
Okay, thank you, Dr. Muhammad, for your presentation. It's my pleasure to present for you our applied research in biomedical engineering based on artificial intelligence at Beirut Arab University. Is a first project. It's about development of a new biometric approach, where the aim of this work, the aim of to identify or recognize a person from their heartbeat using a new feature extraction with machine learning tools to classify the ECG data of the
Continue. Go ahead.
This is the identification program for this project.
It's okay, go ahead.
This work is published on International Journal of Biology and Biomedical Engineering in USA 2020. The second project it's about a novel ECG wave detection followed by a new compression technique based on Fourier series modeling for up 26-day Holter monitor. The aim of this study is to extend the ECG recording time from 1 day to up 26 days.
ماشي عندهم ما نضيع شيء طالع على خطك
This work why Holter monitor some heart disease, because some heart disease need continuous monitoring over a long period of time to evaluate chest pain, to identify a regular heartbeat, to see how well a pacemaker is working, and so on. After in this project, in this research we use the same methodology of ECG biometric project, but for wave modeling we use the Fourier transform instead the sum of sign model to calculate the function of the model, and this is to reduce the number of the coefficient calculated. As you see in this table, we can we are able to reduce the number of the coefficient from 15 to 10 by using Fourier transform order 3. As you see in this slide, in the case of the Holter monitors that currently find in the market, 86 million point will be calculated in 24 hours, but based in our algorithm, the number is reduced from 86 million to 3 million, so we can extend the recording time of the Holter monitor from 1 day to 26 days. This is our Holter monitor prototype, where our algorithm will be uploaded on Raspberry Pi module. This work is published on ICA BME 21. The third project is about adaptive neuropathy inference system as a new real-time approach for Parkinson seizure prediction. The aim of this project is to predict the pre-seizure of the Parkinson. Then in this project, we use the adaptive neuropathy inference system. That is an advanced approach on AI that combine the benefits of artificial neural network and fuzzy logic in one algorithm called ANFUS. So in this case, we train ANFUS by a normal data as you see here. Then we'll checking ANFUS by the pre-seizure data. The obtained error will be decreased in this case. As you see here from the data or from the error calculated on the normal case and the error calculated from the pre-seizure case, the difference between the two errors, it's the degradation curve represented in the figure in the image below. To calculate the variation technique, we use S of t as an equation to calculate the prediction time, that is T2 minus T1. This work is published on BioSmart 2021 in Paris. The project number 4 is bringing AI to automatic diagnosis of diabetic rational therapy from optical coherence tomography angiography. The aim of this project is to classify between normal and diabetic retinotherapy using deep learning tool. This work is published on ICA-BME 21 also. The project number 5 is a new AI-based framework for thalassemia diagnosis. The aim of this project is modeling and the classification of thalassemia. The project number 6 is designing of a new static stability platform. The aim of this project is to design a stabilometer platform able to make the proper diagnosis and rehabilitation of body imbalance. Why stabilometer? The stabilometer is used on the case of we have a curvature of the spinal cord, unequal leg length, Parkinson, flat and hollow foots. This is the block diagram of the stabilometer platform. We have 3 force sensors connected to an amplifier, then to the data acquisition system, then to the computer to calculate the center of pressure of the patient. And depending on this center of pressure, we can diagnose the physiological problem of this patient. A software is designed to diagnose the instability degree and to treat the patient. For diagnosis step, some parameter like center of pressure and the data surface must be calculated, as you see in this slide. This graph represents a normal case, or a stability person, and this is represent a abnormal case or unstable person. This slide represent, as you see, the surface of data increase if the person is shivering of or he vibrate. This work is submitted to BAU journal. The 7th project is mobile application for automatic Petri dish antibiogram reading and analysis. The aim of this research is to design a prototype that automatically read and interrupt Petri dish antibiogram using circle hoof transfer and pixel value checking. Usually the circle of Petri dish is measured by vernier clapper, and it's need more than 30 minutes for one Petri dish. For our project, a smartphone is used to acquire the Petri dish image, and the circles will be detected and interrupted by MATLAB mobile software. Our methodology is success to detect the circles in the Petri dish. This is the obtained report of results. The project number 8 is development of a system for detection, diagnosis, and treatment for eye strabismus disease. First, we put electrode around the eye of the patient to acquire the vertical and horizontal EOG data. Then we plot the horizontal EOG in terms of the vertical EOG to obtain the center of the vision. For the diagnosis, many parameters are calculated, such as deviation of the vision gravity center and the data surface. The doctor depends on this parameter to determine the type of the treatment. The doctor treats the patient by a series of exercise like games. This is table showing the importance of our device in the treatment of strabismus. This work is published on ICA-BME 21. The project number 9 is a new AI approach for automatic.
The last one, or we still have?
You still have one project.
Quickly.
A new AI approach for automatic gait pattern abnormalities analysis to control human motor disorder using deep learning. The aim of this project is to classify between normal and abnormal gaits, like Parkinson gaits and hemiplegic gaits. using AI. Based on this, on that classification, the system will deliver a specific biofeedback to the patient. The last project is development of a new BCI, brain-computer interface technique for disabled person. The aim of this project is convert cognition into a command. This is the block diagram of our project. First, we ask the patient to look to RGB screen and then record the EEG signal. Then feature extraction will be calculated, followed by a advanced AI classification and control step. Using this approach, the patient able to do a home automation process just by thinking. At the end, thank you for your attention, and for more information, feel free to contact me. Thank you.
Thank you, Dr. Ala, for this presentation and for this intensive research activity. Unfortunately, for lack of time, we will not be able to take questions. If you have any questions, please directly you can contact the presenters. We will move to Dr. Subhi Abu Shaheen to present us the closing discussion and recommendations. Dr. Subhi, the floor is yours.
اعمل سبوت على بليز. بديش انا حابب اقرا عليه. اعمل سبوت لايت على مبين بالشاشه. Okay. At the end, excuse us to have a long day today, especially in the late evening, in the evening. So we are here almost for 3 or 4 hours. Thank you, Dr. Ala, for the presentation, and hoping since we are dealing with this work package with collaboration with industry, that our research in all our universities, not with you only, with Dr. Muhammad Khalil also, thank you, Muhammad, and also thanks for all speakers, hoping that in the next time, in the next years, in the coming activities within this project, we can have a strong collaboration with industry, and this research that we presented, or Dr. Khalil, or Mr. Elmir, or others, that we will have common project, common research project, and we can have better collaboration with industry. In this regard, of course, we need to have some conclusive remarks or some collaboration. I identified someone, and we welcome also any suggestions for as deliverable as outcomes of this workshop. I identified someone, for example, we need to communicate to the stakeholders with all the potential AI projects for funding, like Mr. Shammes today has presented. So we are ready to cooperate with Mr. Mallat, for example, to identify research project also. For example, Dr. Ala and Dr. Muhammad Khalil presented large amount of research projects. So if this project will be with, as Dr. Khalil said, with hospitals or with doctors or with just to have more impact for this research and to have application on AI, artificial intelligence. Also, we need that the industry to provide us with internship for students on different levels. I mean by different levels, as Mr. Mallat said, not only for the final year project, from the beginning, to start with the required competences needed for the employability of graduates after that, especially in AI. At the same time, as I said with Dr. Ala, we need also to conduct common research project with industry, as well as Dr. Clovis, between institutions and between partner institutions, between, for example, Lebanese University, Jordan University, BAU, and Jordan University, and so on. And with our, because we forget to, Dr. Ala Ayad told you that this project is in collaboration with EU in the university from, I think, from Spain, from Italy, from Germany, from Greece, all of this. So we need to identify research project on that. At the same time, also to strengthen the collaboration with the industry, we would like to invite AI industry experts to participate in both teaching some courses, some relevant courses, some relevant projects, and also to organize relevant seminars and workshops on future activities relevant to artificial intelligence. And at the same time, we are ready also, I think, on behalf of BAU as well as Lebanese University and Lebanon, to sign MOUs, Memorandum of Understanding, between universities and industries and partnerships. And at the end, I would like to thank you on behalf of BAU and Lebanese University and DCARE Consortium team. Thank you also for your participation. Dr. Clovis, you can close. Many thanks for everything.
Many thanks for all the presenters, for your time, for your engagement, for your information, for your inputs. It's valuable for us, for our project, for our deliverables. Many thanks for all the persons who attended online or in person. Many thanks to BAU for hosting us, for preparing everything. Thank you from the bottom of our heart. Thank you, Dr. Reis, for this project coordinator, for your initiatives. And we hope to meet all of you in person next time. Professor Reis, if you want to add something to comment, please go ahead. The floor is yours.
I'd like just to thank all of you for organizing this excellent workshop. I hope that this is a good start, and I hope that this workshop will open a better cooperation and collaboration between the industry and the universities, so that our students and our efforts are better tuned for the benefits and needs of our communities, industry, and local organizations. Thank you again. Bye-bye.
Thank you. Thank you. Hoping next time face-to-face, not online. We're hoping next time we meet face-to-face, all of us.
Sure, sure.
Thank you very much and have a nice evening.
Ciao.
الله انك ما شاء الله عليك.
خليك
خذ برنت سكرين. برنت سكرين او بيست. بدنا ناخذ صورة خليكم اعمل.
وين برنت سكرين؟
مش هتفتح البرنت.
لا.
بدك تكبس هي مع الشيفت، هي بدك تكبس فانكشن يمكن. فانكشن مش هلا. هلا على الزوم. على الزوم تمشي الحال. لا طيب ماشي. رجع الزوم. اوكي هلا يلا بدنا ناخذ صوره.
فانكشن مال فانكشن
مال هاي بس طلعوا بالكاميرا هون. ايوه طلعوا بالكاميرا. اوكي عن او عن كنترول دي. ظبط لنا الوضع.
شغل معلمين شو بك كل يوم نعمل. طيب thank you very much. I will end the meeting and شو بدنا نعمل؟ هو بيعمل stuff.